This is Jacob's Algebra, Chapter 12, Lesson 6. This lesson is about dividing square roots. So remember, we've gone over many times the pattern for the difference of two squares. If you have a plus b and you multiply it by a minus b, you will get a squared minus b squared. So anytime you have the sum of two terms multiplied by the difference of those same two terms, what you will end up with is the difference of the two squares. Now, I want you to see we have, there's something called a conjugate, which we talked about in class. The conjugate of the sum of two terms is the difference of two terms. The conjugate of the difference of two terms is the sum of two terms. So if we have x plus the square root of y, the conjugate of that would be x minus the square root of y. If we had x minus the square root of y, the conjugate would be x plus the square root of y. If we had square root x minus y, the conjugate would be square root x plus y. If we had square root x plus square root y, the conjugate would be square root x minus square root y. So whichever, it doesn't matter whether you start with the sum of two terms or with the difference of two terms. If you have the sum of two terms, the conjugate is going to be the difference of those same terms. If you have the difference of two terms, the conjugate is going to be the sum of those same two terms. Now I want you to notice that this works even if your first term is negative. Let's say we had negative square root x plus y. The conjugate would be negative square root x minus y. What we're going to do is just copy the exact same thing we had and then flip the sign that's in the middle. Now I want you to notice when you multiply x plus square root y times x minus square root y, which are conjugates of each other, what you will end up with is the square of the first term, which is x squared, minus the square of the second term, which is just y, because the square root of a number times the square root of the same number is the number you were taking the square root of. So if you have square root 3 times square root 3, that's 3. If you have square root 937 times square root 937, that's 937. So let's try this second pair of conjugates. We've got square root x minus y and square root x plus y. What we end up with is square root x times square root x is just an x. Y times y is a y squared, so it's x minus y squared. If we do square root x plus y times square root x minus y, square root x squared is x squared. It's just x. Square root y times square root y is just y. So we end up with x minus y. And then the last one that we have on here is negative square root x plus y times negative square root x minus y, conjugates again. If we square our first term is negative square root x. When we square that, we get just a plain x, because negative square root x times negative square root x is a positive x. And then we're going to subtract y times y squared. I want you to notice that over here on the right, our product, there are no square roots over here. So anytime that you need to get rid of a square root that's in the denominator of a fraction, if you multiply by the conjugate, you will end up eliminating your square root, which is what we need to do. We talked a couple of lessons ago about how we never leave a square root in the denominator of a fraction, and we never leave a fraction inside of a square root. What you need to do is rationalize the denominator. It's called rationalizing because rational numbers are, it's a particular set of numbers, and square roots are irrational numbers. So when you rationalize the denominator, you make it something that doesn't have a square root in it anymore. You make your denominator rational. So let's do a couple of examples. If we have something like 2 over the square root of 3, how would we rationalize that denominator? Well, what we need to do is multiply square root 3 by something that will give us a square. So if we multiply this by square root 3 over square root 3, what we'll end up with is 2 times square root 3 is 2 root 3. Square root 3 times square root 3 is just a 3. We no longer have a square root in the denominator. If we had 1 over 3 plus root 6, to get rid of this square root, what we'll need to do is multiply by the conjugate of our denominator. We have 3 plus square root 6, so we need to multiply by 3 minus square root 6. Write down the same terms, we just flip the sign in the middle. When we multiply this out, 1 times 3 minus root 6 is 3 minus root 6. And we're going to divide that by the square, the first term squared. 3 squared is 9, minus the second term squared. Square root 6 squared is 6. So we have 3 minus root 6 over 3, because 9 minus 6 is 3. We'll do one more example. What if we have 4 over square root 7 minus square root 3? We need to multiply by the conjugate of our denominator. That's going to be square root 7 plus square root 3. We copy down the same two terms, square root 7 and square root 3, and then we change the sign in the middle. We had a negative, so we need to write a positive. Square root 7 plus square root 3. This will give us an equivalent fraction. So 4 times root 7 is 4 root 7. 4 times root 3 is 4 root 3. And then we have our first term squared. Square root 7 squared is 7. And then we're going to subtract our second term squared. Square root 3 squared is 3. So we have 4 root 7 plus 4 root 3 divided by 4, because 7 minus 3 is 4. Now you can see we have a 4 everywhere in our numerator. We can divide this entire fraction, the top and the bottom, by 4, and what we'll end up with is square root 7 plus square root 3, because 4 root 7 divided by 4 is root 7, and 4 root 3 divided by 4 is root 3. Okay, let's work some sample problems now. We're going to start with number 4. The instructions for number 4 say divide and simplify. So let's look first at part A. We have square root 100 over square root 4. Anytime you're dividing two square roots, you can put those two square roots together into one fraction. This is the square root of 100/4. We can simplify that fraction. 100 divided by 4 is 25, and the square root of 25 is 5. Let's take a look at another one, part C. Part C is the square root of 21 divided by the square root of 84. We can rewrite that as just the square root of 21 over 84. Let's go ahead and simplify our fraction since we don't have a square number. 21 84ths, they're both multiples of 7. So 21 divided by 7 is 3. 84 divided by 7 is 14. Let's see, 7 goes into 8 one time. It's 12. So it's 3/12. And then when we simplify that a little further, we can divide both of these by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So we have the square root of 1/4, and that is 1/2, because the square root of 1 is 1 and the square root of 4 is 2. Let's take a look at part E. Part E is the square root of 60 divided by the square root of 5. That's the same as the square root of 60/5. When we divide 60 by 5, we get the square root of 12. Now, the square root of 12 can be simplified because there is a square factor. we could write 12 as 4 times 3. Now, an important thing here when you do go and rewrite your what's inside of your square root as the product of two terms, when you pull out that square factor, you have to remember to square root it. So 12 is 4 times 3, but to be able to pull this out of the square root, I have to take the square root. The square root of 4 is 2, and then we still have a 3 left behind inside of the square root. Okay, the last one here we're going to do is part F. Part F is square root 2 over square root 10. That is the same as the square root of 2/10. We can simplify that fraction to the square root of 1/5. And now to rationalize this, we need to get a square number in the denominator. Well, if we multiply by 5/5, that will get us square root 5 over 5. Because in our denominator, we will have 5 times 5, which is 5 squared. And when we take the square root of 5 squared, we just get a 5. In our numerator, we had 1 times 5, which is 5, and we can't do anything else with that. So the answer to part F is square root 5 over 5. So this was number 4, which is just like number 12 that I assigned for homework. Let's look now at number 6. The instructions for number 6 say divide and simplify. So let's look at part C. Part C is square root of 3x cubed over square root of 12x. I'm going to write this as a single fraction, 3x cubed over 12x. I can simplify my coefficients because 3 divided by 12 is 1/4. So we've got a 1 on the top and a 4 on the bottom. X cubed divided by x, that is x squared. So what I have now is x squared over 4. I have a 1x squared written here, but that's okay. The square root of x squared is x. The square root of 4 is 2. So we end up with x over 2. Let's look at part D. Part D is the square root of 8x to the 8th divided by the square root of 2x squared. We're going to go ahead and make this all one fraction inside of our square root. So we have 8x to the 8th over 2x squared. 8 divided by 2 is 4. So in our square root, we have a 4. X to the 8th divided by x squared is x to the 6th. Remember, when you're dividing numbers that have powers, we subtract the powers. Now, when we take the square root of this, the square root of 4 is 2. The square root of x to the 6th is x to the 3rd. Remember, a square root is a half power. Anytime you take the square root of something that has a power, you need to cut that power in half. That's what a square root does to powers. It's going to cut the power in half. So that was number 6. It's just like number 14 that I assigned as homework. So let's take a look at number 7. Number 7 says write the conjugate of each of the following expressions. So let's take a look at these. For part A, we have 8 plus the square root of 2. The conjugate of that, we're going to copy down the same two terms, 8 and square root 2. We had a positive, so the conjugate is going to have a negative in the middle. Part B, we have square root 15 minus 6. We're going to copy those same two terms in the same order. We had a negative, so we're going to change it to a positive. So these are the conjugates. Okay, part C, we have x minus square root y. We're going to copy those same two terms, x and square root y. We had a negative, so we're going to change it to a positive. And then part D, we have square root x plus square root y. We're going to copy those same two terms, square root x and square root y. We had a positive, so we're going to change that to a negative. So remember, when you're writing the conjugate, you copy the first and second terms just as they are, and then whatever sign was in between them, you're going to change it to the opposite. So if you had a positive, you will change it to a negative. If you had a negative, you'll change it to a positive. So the rest of the problems we'll go over in the part 2 video.